Okay, let's find the x and y intercepts of the following, the graph of the following equation and sketch its graph. So the x-intercept happens when y equals 0. So I pop that into the equation and I get 0 equals x squared over 9 minus 1, or x squared over 9 equals 1, or x squared equals 9, which gives me x equals plus or minus 3. So I have the graph of this equation cuts the x-axis in two places. Now how about the y-axis? The y-intercept occurs when x is 0, and that is y equals 0 minus 1, or y equals minus 1. So we have a unique point where the graph of this equation cuts the y-axis. Let's plot a few points and then join the dots. In this case, for a given x value, we have a unique y value on the graph, and we have a formula for that. So we can use that to find a few points on the graph. Let's follow tradition here and take the points minus 3, minus 2, minus 1, 0, 1, 2, and 3. What happens when I plug in x equals 3 here? Well, since this is going to be an intercept, I should get 0. Y equals 9 over 9, 1 minus 1, which equals 0. So we have the point minus 3 zeros on the graph, but there's nothing new there. We knew that already. When I plug in x equals negative 2, I get y equals 4 over 9 minus 1, which is minus 5 over 9. So the point negative 2, negative 5 over 9 is on the graph. When I plug in x equals negative 1, I get y equals 1 over 9 minus 1, which is minus 8 over 9. And so the point minus 1 minus 8 over 9 is also on the graph. When I plug in x equals 0, I get y equals 0 minus 1, which is minus 1. So the point 0 minus 1 is on the graph, and that, of course, we found already is our y-intercept. When x equals 1, y equals the same thing we got when x equals minus 1, because the x is squared in the formula. It's 1 over 9 minus 1, which is minus 8 over 9. So I have some symmetry here, which we'll see on the graph in a moment. When x equals 2, I'm going to get the same answer as when x was negative 2. Y is 4 over 9 minus 1, which is minus 5 over 9. So the point 2 minus 5 over 9 is on the graph. And when x equals 3, y equals 1 minus 1, which equals 0. So the point 3, 0 is on the graph, which isn't really news because we knew the x-intercepts were at plus and minus 3. Now let's just extend this a little bit and choose x equals 4. And we have y equals 16 over 9 minus 1 in this case. And now we get a y value greater than 0. So this is equal to 7 over 9. And we get the point 4, 7 over 9 is on the graph. Let's draw a picture. Okay, so our first point is minus 3, 0. That gives me a point on the graph. Minus 2, negative 5 over 9. That's a little more than negative 1/2, so that's about here. -1, -8 over 9. It's about here. 0, -1 is here. 1, -8 over 9 is about here. 2, -5 over 9 should be directly across from -2, -5 over 9. So it's here. And 3 zeros here. And 4, 7 over 9 is about here. And you can see by the symmetry we talked about, we should also have -4, 7 over 9 on the graph. So we get this parabola. My guess is that should be about there. And we assume this keeps opening upwards. And the graph of this equation is a parabola, which is also a conic section. This is when you slice a cone, but instead of the slice reaching the other side, it hits the end of the cone. And so the exposed part of the cone looks like this. Technically, these sides go on forever if you have a cone stretching off to infinity.